Hello, my name is Noor Shafika.
Hi everyone, I'm Alia Mesara.
Hi, my name is Nurlisa Adrina.
Hello, my name is Shasha Nazira.
In this project, we were asked to innovate an item, so we had to choose a fan. Good morning, everyone. Today, our group would like to present our physics innovation project called the Smart Sensor Fan. This fan uses thermal and rotational mechanics to work smarter. Instead of spinning at one fixed speed, it adjusts automatically based on the room's temperature and movement around it. The goal is simple: to improve comfort while saving energy. To plan this project, we use a model called the NABC framework. It's common in innovation and design thinking. NABC stands for N, need, what's the problem? A, approach, how do we solve it? B, benefit, why is it better? C, competition, compared to other solutions. This helps us stay focused on solving real-world problems with smart and practical ideas. In Malaysia, we deal with hot and humid weather almost all year. Fans are everywhere, at home, in school, even in office. But most of them just spin at one speed, no matter how hot or crowded the room is. That's not very efficient. So we saw a need for a fan that can think and adjust on its own. Our idea is based on the concept of convection, heat transfer through moving air. A fan pushes air across our skin and removes heat, cooling us down. The faster the air moves, the faster we feel cold. That's why understanding this principle helps us design a fan that cools more efficiently and only when needed.
Hi, I'm Noor Shafika. I'm going to continue from the introduction. I will now explain more about the need for our smart sensor fan. In Malaysia, the weather is hot and humid all year, but the heat becomes especially intense between March and September. This affects everyone, especially students, children, and the elderly, who are more sensitive to temperature change. Without proper cooling, people struggle to sleep, focus, and stay comfortable indoors. In more serious cases, it can even lead to mild dehydration or heat stroke if airflow is poor. That's why we believe just a normal fan is enough anymore. People need a smarter solution that responds to real conditions, not just one speed setting. So our solution includes a thermosensor, a key component in physics that detects the ambient temperature. The sensor sends signal to the fan motor, and the system automatically adjusts the fan speed depending on how hot or cool the room is. This allows better comfort without wasting electricity or needing to manually adjust the fan all the time. It's smarter, more energy efficient, and safer, especially for long hours of use during sleep or study. Based on that data, the fan automatically increase or reduce its speed. This creates a feedback system. When the room is hot, the fan spins faster. When it's cool, the fan slow down or stop.
Hi everyone, I'm Alia Mesara and I will be presenting part of our project which focus on our approach and the rotational mechanics, specifically torque, involved in our design, the smart sensor fan. Our solution is a smart sensor fan that uses temperature, humidity, and motion sensors to operate more efficiently. It can auto-adjust its rotation speed and direction depending on the environment. When no one is present, the fan automatically turns off to conserve energy. We also propose an optional solar panel version, making it an environmentally friendly choice. Next, how does it work? The fan uses built-in sensors to monitor the surroundings. Based on the input, it adjusts its behavior in real time. This not only keeps the room comfortable, but also reduces electricity usage by avoiding unnecessary spinning. It's a smart, responsive system. Now, let's connect these to physics, specifically torque. Torque is the rotational force that causes the fan blades to spin. It's calculated as force multiplied by the radius of the fan shaft. The more torque applied, the faster the fan spins. But this also means more energy is used. So, managing torque is key to efficient fan operation. Here's where smart control comes in. The fan's control system only applies the exact torque needed based on the current conditions. For example, if it's cool or no motion is detected, the fan will spin slower or turn off. If it's hot and people are present, it increases torque and speed. This ensures the fan delivers comfort without wasting energy. To summarize, our smart sensor fan is not only user friendly, but it is also integrates physics and engineering. By linking environmental sensors with top control, we have created a solution that's smart, energy efficient, and customizable. It's a great example of how rotational physics can be applied in real world product design.
In this final part, I will explain how we use physics to improve our smart fan. We focus on two key concepts, rotational mechanics and thermal physics, especially convection. This helps the fan spin efficiently, cool faster, and respond to the environment automatically. Let's start with rotational mechanics. First, we apply torque, which is the force that causes rotation. The formula is torque equal to R multiplied F, where R is the distance from the center and F is the force. Next is moment of inertia, or I, which is the fan's resistance to spinning. By using lighter fan blades, we reduce the moment of inertia, which means the fan can spin faster using less energy. And lastly, we control angular speed, which is changed based on temperature or movement. So if the room gets hotter, the fan spin faster. And this way, the airflow increase only when needed. Now let's move to thermal physics, where we focus on convection. Convection is the transfer of heat through moving air. When the fan blows air across your skin, it absorbs your body heat and carries it away. Hot air rises because it's less dense, and cooler air it takes its place. This creates a continuous cycle. Our fans support and speed up this natural process, which help increase the cooling effect. So instead of just moving air around randomly, it actually helps remove heat from your body effectively. Here's where physics meets technology. Our smart fan uses two sensors that help it adjust automatically to its surrounding. The first is a temperature sensor. When the room temperature gets higher, the sensor detects the heat and the fan increases its angular speed to improve cooling. This means the fan doesn't run at the same speed all the time. It changes based on how the hot room is. This helps save energy while still keeping the room comfortable. The second sensor is for motion detection. If someone enters the room or moves nearby, the motion sensor activates the fan automatically. It can also redirect effort towards the moving person, making the cooling effect more efficient. So instead of running all the time, the fan responds only when needed. In conclusion, our smart fan is a practical example of how physics can be used to improve everyday life. By applying rotational mechanics and convection, we create a fan that is not just energy efficient, but also responsive to its surrounding. It cools faster, saves power, and adjusts itself automatically, making it ideal for home, office, school, or even hostels, especially in hot climates like Malaysia. A solution like this can make a real difference. And with science and a little creativity, we turn a basic fan into something smarter, greener, and more useful.